Welcome to The Explainer, where we break down the biggest ideas shaping our world. Today, we're talking about the end of an era, the physical limits of our digital age, and the two absolutely mind-bending paths that are opening up to take us into the future. Okay, let's just start with that quote. That is a huge statement from one of the world's most famous physicists. It sounds like something out of science fiction, right? But it's actually signaling a massive shift in technology that's already happening. To really get why he'd say that, we have to look at the engine that has powered our entire world for the last half-century. For over 50 years, computing has been defined by one really simple, really powerful idea. It's the reason the phone in your pocket is unbelievably more powerful than the computers that sent humans to the moon. But that era, the one we've all just taken for granted, is coming to a close. And it all comes down to this: Moore's Law. It's this relentless, predictable doubling that's driven the entire digital revolution. It's why our gadgets get faster and more powerful every single year. But this exponential party, well, it's about to be shut down by the fundamental laws of physics. So here's the wall we've hit, and I mean a literal physical wall. We've made transistors, those tiny on-off switches that are the building blocks of all computing, so incredibly small that they are now just a few atoms thick. And when the barrier that's supposed to stop the flow of electricity gets that thin, electrons start to do something really weird. They can literally tunnel through it, even when the switch is off. That creates short circuits, and it's the fundamental reason we can't just keep shrinking our chips forever.
With the old way ending, scientists and tech giants are now in a race, exploring two totally radical new paths forward. You can think of them as two wormholes to a completely new computational universe. Okay, so this first path isn't just about making computers a little bit faster. It's about rebuilding them from the ground up, based on the strange and incredibly powerful rules of reality itself. We're talking about computing with individual atoms across parallel universes.
This slide really gets to the core of it. Your laptop uses classical bits. Think of it like a light switch. It's either on or off, a 1 or a 0. It solves a maze by trying one path at a time. But a quantum computer uses qubits, and a qubit can be a 0, a 1, or somehow both at the same time. It explores every single path in the maze instantly and simultaneously. So just how powerful is this leap? Well, in a recent breakthrough, Google showed its quantum chip was 13,000 times faster than a traditional supercomputer on a specific task. To put that into perspective, certain problems that would take a normal computer 10,000 years to solve could be cracked in just a few seconds. The implications here are just staggering. We're talking about potentially curing diseases like Alzheimer's by modeling them at the atomic level, maybe solving our energy crisis with fusion power, and oh yeah, cracking basically all modern digital encryption. It's no wonder every major government and corporation is pouring billions into this race. All right, let's jump into our second wormhole, which, if you can believe it, might be an even more mind-bending vision of the future. This path takes us beyond silicon and straight into the realm of biology. I know, it sounds like something straight out of a movie, but researchers are now actually merging living human brain cells with electronics. They're creating a new form of intelligence in a brand new field called biocomputing, or wetware. So why would we do this? Well, the key advantage is just breathtaking efficiency. As this chart shows, a modern supercomputer can consume enough power to run thousands and thousands of homes. Your brain? It runs on about 20 watts, the same power as a dim light bulb. Nature, it turns out, has already built the ultimate low-power computer.
And this is not just a theory. In an amazing experiment called Dish Brain, scientists grew about 800,000 neurons on a chip. That's roughly the brain size of a bumblebee, and they taught them to play the video game Pong. By rewarding successful hits with predictable electrical signals, the neurons learned in just minutes how to control the paddle. They were literally trying to make their world less surprising. They were learning.
So these breakthroughs in both quantum and biocomputing, they're more than just powerful new tools. By harnessing the fundamental strangeness of reality itself, they are forcing us to confront these really profound questions about the nature of the universe and, our place within it. So for physicists like Roger Penrose, the weirdness of the quantum world, where a particle can be in two places at once until it's measured, is simply an objective physical process. The universe decides on its own, not because a conscious person is looking at it. In other words, the moon is still there even when you're not looking. But then, for philosophers like Slavoj Žižek, quantum theory suggests something far deeper.
It implies that the universe isn't some fixed set of facts just waiting for us to discover them. Instead, reality itself is an unfinished project, a world of possibilities that only becomes concrete when we interact with it. And this debate takes us right to the core of what it means to exist. We're building machines that operate on these bizarre principles, and in doing so, we might be changing our own understanding of what is even real. Now, make no mistake, this is not science fiction for some distant future. The race to build these machines, to control this new reality, is happening right now, and there are billions of dollars and global dominance at stake. Just look at how fast things are accelerating. We go from a theoretical observation in 1975 to lab-grown brains playing video games in 2022. The target for quantum computers to actually have real-world applications is just a few years away. And the big goal? A million-qubit machine, a computer with power that is beyond our current comprehension. And this is why this all matters. Think about it. The invention of the transistor created Silicon Valley and completely shifted global power. Well, the race for quantum and biocomputing could be just as disruptive, if not more so. The nation that masters this technology could control everything from global finance to national security. So this really isn't just a question for scientists in a lab anymore. It's a question for all of us. We are building machines that compute with universes and think with living cells. The end of the Silicon Age is here, and what comes next could redefine not just our technology, but ourselves.